All right, in 1.8, we're going to do box plots and outliers. Okay, it's another way to display quantitative data. So Barry Bonds set the major league record by hitting 73 home runs in a single season. The dot plot below shows the number of home runs that Bonds hit in each of his 21 completed seasons. Bonds' 73 home run season stands out, it's the one in red, from the rest of the distribution. Should this value be classified as an outlier? It sure appears that way because there's a gap, but there is a way to know for sure if it's an outlier, so we're first going to look at that. Besides serving as a measure of variability, the interquartile range, remember we've talked about this before, interquartile range, remember, is Q3 minus Q1, is used as a ruler for identifying outliers. Okay, to call an observation an outlier if it falls more than 1.5 IQRs above the third quartile or below the first quartile. Okay, so here it is in math speak. It's a low outlier if it's less than Q1 minus 1.5 IQRs. It's a high outlier if it's Q3 plus 1.5 IQRs. Okay, so think of it as with the baseball analogy. This is the fence. Okay, what we're finding is the fence. If it's outside the fence, then it's an outlier. Okay, so this is going to create our fence, our low fence and a high fence on our data. And I'll show you how to work it out. But it's always this formula. All right, you can use a dot plot, a stem plot, or a histogram to display the distribution of a quantitative variable. Another graphical option is a box plot. Sometimes it's called a box and whisker plot. A box plot summarizes a distribution by displaying the location of 5 important values within the distribution, known as the 5-number summary. The 5-number summary is a distribution of quantitative data, consists of the minimum, the first quartile, the median, the third quartile, and the maximum. Okay, you will be expected to know that. It goes minimum, Q1, median, Q3, and the max. And from those 5 pieces of information, we can calculate outliers and draw a box plot. That's what you need. The box plot is a visual representation of the 5-number summary. Remember, your calculator is going to give you these 5 pieces of information. So it's pretty simple. So here's the steps you're going to use. First, find the 5-number summary using your calculator. Number 2, draw and label the axis. There's only one. Draw a horizontal axis and put the name of the quantitative variable underneath. You've got to label your axis. Points will be deducted if we do not label. Scale the axis. Look at the smallest and the largest values in the data set. Start the horizontal axis at the number equal to or below the smallest value and place tick marks at equal intervals until you equal or exceed the largest value. Okay, so this is neatness matters. You've got to stop and think about how to scale your axis. Then you're going to draw a box, and it spans from the first quartile to the third quartile. Okay, that's where your box goes. And within the box, you're going to mark the median. It's just a vertical line segment that's the same height as the box. I'll demonstrate here in a minute. Number 6, identify outliers using the 1.5 IQR rule. Okay, we'll practice that in a second. And then lastly, draw whiskers, lines that extend from the ends of the box to the smallest and largest data values that are not outliers. If you found an outlier, like in step 6, you're going to mark that with an asterisk or a star. And then your whisker would go to the next highest or next lowest value. All right, so let's look at one. Okay, so here's Barry Bonds' home runs again. And what we've done is we've kind of given up the data here. Okay, we found Q1, we found the median, and we found Q3. All right, so when we take a dot plot and we get those 5 pieces of information, make it a box plot, look what happened. Here's our box. Q1 and Q3 are the ends of our box. The median is a vertical line within the box. Right? And then we calculated outliers. Okay, 1.5 IQRs is 29.25. So we didn't have anything lower than our fence over here. Okay, we subtracted that 29.25 from this point right here, or no, from We subtracted that 29.75 from our Q1 value, and we didn't have anything lower, so we have no outliers down here. Then we took Q3 and we added 29.25, and there was no outliers out here. Okay, 75 fell within that fence, so it's not considered an outlier, surprisingly. So then we draw whiskers to our minimum and our maximum. All right, that's all you have to do to make a box plot. Now, box plots provide a quick summary of the center and the variability of a distribution. They do not display each individual value in the distribution. They don't show gaps, clusters, or peaks. So there is a downside to box plots, but we tend to use them quite a bit because they are a good summary visual of a set of data. They're especially effective for comparing the distribution of a quantitative variable in 2 or more groups. Okay, so this is the number of text messages in a 2-day period between males and females. So notice you have a table here and you have the 5-number summary for each the males and the females, and then the created box plots. And you can quickly see that the females tend to give more text messages than males. Look at the median line in the middle there. The median is higher. Okay, median is here for females and it's right here for males. So females tend to give more text messages. There are a few outliers of men, but for the most part, most men fall down here. Okay, women, there's a wide range of it, but in general, they are higher than men. All right, so let's try one of these. The roster of the Dallas Cowboys professional football team in a recent season included 7 defensive linemen. Their weights in pounds were 321, 285, 300, 285, 286, 293, and 298. Identify any outliers in the distribution. Show your work. All right, so the first thing you're going to have to do to find an outlier is go to your calculator and enter that data in the list. Okay, so I've entered the weights. Then you're going to go to Stat, Calc, One Variable Statistics. Again, we've done this before. Choose List 1. And go down where it says the arrow right there. Scroll down and look. It's going to give you the 5-number summary. There it is. 285, 285, 293, 300, 321. So what I'm going to do is copy those values on my paper so I can then calculate an outlier. So to find my low outliers, remember the formula says to take Q1 and subtract 1.5 IQRs. Now, we need to do a little side thing. What's my IQR? It's always Q3 minus Q1. So what is it? 300 minus 285, which is 15. Okay, so Q1 was 285 minus 1.5 times 15. When I put that in my calculator, I got 262.5. All right, that's my lower fence. Now look at my minimum value. There's nothing lower than 262.5, so I do not have any low outliers, so no low. Okay. Now for the high outlier, we have to take Q3 and we add 1.5 IQRs. So Q3 was 300, and we add 1.5 times 15. When I do that, I have 322.5. And I look at my max. My max is 321. It's not higher than this. So there's nothing outside the high fence. So there's no high outliers. All right? That's how you determine an outlier. When you're asked to do that and it says show your work, you got to show your work. And this is the work I'm expecting to see. All right, example 2. According to a study of the Nielsen Mobile, teenagers ages 13 to 17 are by far the most prolific texters, sending or receiving 1,742 messages a month. And Mr. Williams, high school stats teacher, was skeptical about this claim. So he collected data from his first period stats class on the number of text messages and calls they had sent or received in the past 24 hours. And here's the data from the class. Make a box plot to display the data. Right? So to do this, you're going to put this in your calculator like I've shown you. Okay? You're going to go to Stat, Edit, and I put those number of text messages in list 1. You go to Stat, Calc, and one variable statistics, down, calculate, and then if you keep on scrolling down, there's your 5-number summary, and we need that to be able to do the rest of our problem here. So I'm going to write our summary down. All right. Now, before I dive into my box plot, I've got to find if there's any low or high outliers. So I'm going to do Q1 minus 1.5 IQRs. Q3 minus Q1, which is 40, right? So Q1 is going to be 3 minus 1.5 times 40, which gives me negative 57. Okay, I don't have any data points that are negative, so I have no low outliers. High outliers. So I'm going to do Q3 plus 1.5 IQRs. 3 was 43 plus 1.5 times 40. When I did that, 103 is my fin. So look, that 118 is an outlier. So that's important to notice when I do my box plot. Now, to draw the box plot, I draw my axis and label it. Okay, this is the number of text messages per day. Okay, and the highest is 118, so I got to scale this strategically, and the 0 sounds here. So I'm going to do this by 10s. Okay, so it's on there. Now, okay, so our box is this piece right in here. Okay, so it goes from 3 to 43. There's our box. Then we draw the median where the median goes at 9, so it's way down here. It's inside the box. Then we draw the whiskers to our minimum. And our maximum is 118. That was an outlier, so we're going to put a star out there. And then we're going to draw our whisker to the next highest value, which was 92. Which goes right about there. Okay, so there's our box plot. Now, B says, explain how the graph that we just did gives evidence to contradict the claim in the article. So the article claims that teenagers send 1,742 texts a month, or roughly 58 a day. So remember, this is the 25% mark, and this is 75% mark. So 75% of them send 43 or less a day. The article, teenagers, 1,742 per month, which is approximately 58 per day. So we divide by 30, we get. Boxplot shows that 75% teenagers send 43 or fewer texts a day. All right? That's how we can use that boxplot to defend ourselves. All right, example 3. Following boxplots summarize the data on the amount of fat in 12 McDonald's beef sandwiches and 9 McDonald's chicken or fish sandwiches. Compare the distributions of fat content for the two types. Okay, if you remember, when we do this, we're going to use SOX. Shape, outliers, center, and spread. All right, so let's do this. For shape, we look at this shape. Both of these are generally symmetric, kind of in the middle, not too skewed. So we would say both distributions, fat content, are roughly symmetric. Outliers, notice that chicken and fish have one outlier. Chicken and fish distribution, one outlier, while the beef has none. Okay, notice I put it in one sentence. I didn't do separate sentences. That's a comparison trick we will do. Center, okay, remember center, let's look at our medians, okay. Beef tends to have more fat than chicken, okay. Or you could say it the other way around, chicken and fish tend to have less fat than beef. So beef sandwiches tend to have more fat than, and then lastly spread, okay. Look at our spread here. Which one has more variation? Which one is stretched further? Well, look, beef has much more variation than the fish and the chicken. Okay, there's more variation. Beef sandwiches than for chicken or fish. And again, to find spread, you're looking at the width of your box. If your box is really tight, then there's very little variation. But the longer your box is, the more variation. That's what I'm looking at. All right, so this video contains a lot of good information that you're responsible to know. So make sure you're taking good notes, and we'll see you in class.